Negative exponents will give us reciprocals. That's their definition. Over here I've written on the board 3 to the negative second power, and we want to simplify this, meaning we want to write it without an exponent or with a positive exponent. By definition, 3 to the negative second power is 1 over 3 to the positive 2. Now 3 to the positive 2 is 9, so I end up with 1/9. So 3 to the negative 2 comes out to be 1/9, and you can see my negative exponent gives me a reciprocal. Here's our next one. 5 to the negative 3 likewise is going to be 1 over 5 to the positive 3. Now I can take 5 to the third power. 5 times 5 is 25, times 5 again is 125. So you see again I get a reciprocal for 5 to the negative third power. Now let's try some other properties of exponents that have to do with division. How about if we have x to the 10th divided by x to the 4th? I have division with the same base. My properties of exponents tell me that that always results in subtraction of exponents. So let me write my base as x to the 10 subtract 4. I introduce the subtraction sign myself. The exponent in the numerator always comes first, the exponent in the denominator second. 10 subtract 4 is 6, so I have x to the 6th power. I'll move right over to this problem, 5 to the 1 divided by 5 to the 3. Same type of problem, 5 to the 1 subtract 3. I introduce the subtraction sign myself because it's division with the same base, exponent in the numerator first, exponent in the denominator second. That's 5 to the negative 2 because 1 plus negative 3 is negative 2. Using my definition for negative exponents, that's 1 over 5 squared, which is 1 over 25. So I end up with a negative exponent right here, and I use the definition of negative exponents as giving me reciprocals to write 1/25. 2 to the 5th power divided by 2 to the negative 3rd power. That'll be 2 to the 5. Subtract, because it's division, the exponent in the denominator, which is negative 3. So that exponent in the denominator is negative 3. I have to write that second after the subtraction sign that I introduced myself. So that's 2 to the 5 plus 3, because subtracting a negative is the same as adding its opposite, which is positive. 2 to the 8th power, and I'm just going to leave it like that. I won't simplify it. So that's what we do with division with the same base. We subtract exponents. Sometimes that exponent comes out to be negative, and that gives us a reciprocal. I want to simplify this expression, a to the 3rd squared, a to the 4th to the 5th, all divided by a to the 5th squared. I'll start by taking this power raised to another power. That'll be a to the 6th times a to the 20th when I multiply exponents, divided by a to the 10th when I multiply exponents there. In the numerator, I have multiplication with the same base, so I add exponents and get 26. In the denominator, I still have a to the 10th. Subtracting the exponent in the denominator from the exponent in the numerator, I end up with a to the 16th power. So, fairly complicated expression, simplifies down real nicely using those properties of exponents. Here's a quick look at scientific notation. 4.23 times 10 to the negative 3rd power. I want to write that in expanded form. Remember, this is 4.23 times 1 over 10 to the 3rd, because negative exponents give me reciprocals. That's 1 over 1,000. When I divide 1,000 into 4.23, it's going to move the decimal point over this way 3 places. So I'm going to have 0.123 places to 3. So that's the expanded form of this number that's written in scientific notation. Now let's take this number and write it in scientific notation. I'm going to move the decimal point over 1, 2, 3, 4 places, so I get a number between 1 and 10. That'll be 3.57. I multiply by a power of 10 so that this number comes out to be equal to this number. I look at it this way. Here's a small number. I made it larger when I wrote it as 3.57. I've got to multiply by a small number to make up for it. I moved the decimal point over 1, 2, 3, 4 places. So I'm going to multiply by 10 to the negative 4th, which is a small number. So back and forth between scientific notation and expanded form using the numbers that have negative exponents.